which starts on approximately page 328. Your book calls them properties of logarithms. Some other textbooks that I've used call them the laws of logarithms. Either way, they're the same things. There are 3 of them. And that's all we're going to focus on today is just the laws or the properties, whatever you want to call them. Okay? So, the first one goes something like this. If you have log, what letter do you want to use for the base? A? Base A. And we'll go capital A, B. Okay? Now notice A and the B. What operation am I doing between A and B? Multiplying. Right. Now, little a and big A, just so that you guys know, when you represent them in this type of format, they are 2 distinct different things. Lowercase a and uppercase A are 2 different things. So, do not think they cancel out. Remember we talked about that yesterday on your test, where if they were the same base, then it was equal to the exponent. They're not the same. Capital A and lowercase a are 2 different things. Okay? Now, one of the things that you're going to do today is you're going to expand, much like you do at Thanksgiving time. So what happens with this is that adding or multiplication is the same as adding. So what you do is you take your pieces and you split them apart by adding. So when they're multiplied, then you split them into log base A plus log base A B. Adding is the same as multiplication and vice versa. So if you have 2 things that are multiplied together, if they want you to expand it, they want you to show them being added to each other. Okay? Law number 2. If multiplication was like adding, what do you think law number 2 is? Yeah. If you have A divided by B, you guys said division and subtraction. You're absolutely correct. Division is the same as subtracting. Log base A minus log base A B. Now again, today what you're going to do is you're going to expand, which means if you have the A times the B, you're going to end up switching it out to adding. If you have A divided by the B, you're going to switch it out to the subtraction. So you're going to make it longer. So you might have this nice little itty bitty problem, and then by the end your answer is going to be the whole length of your page. Okay, that's what could happen. All right? Then tomorrow, we're going to condense them, which means we're going to take the long ones and make it into one little itty bitty. Okay? But that'll be tomorrow. There is one more law or property, and that deals with exponents. If you have log base A to the C, okay? Again, lowercase a, uppercase A are not the same numbers. They're not the same bases. Okay? So in order to get rid of the exponents in the expansion phase, the exponent goes to the front. So this piece right here will now go to the front, which means C times the log of A. Now, just so that you guys are aware of this, one of the other things that I do from time to time, and I wanted to make sure you guys are okay with that. Notice how I uppercased some of my logs and then I lowercase a log? Is uppercase versus lowercase when you write the word log any different? No. Just so that you know that. But if I do it with the bases or when I do it that way, then yes, they are different. But not with the logs. Okay, that's just going from lower to upper, and it doesn't matter for the log part. But the A's, yes, it would. Okay? You are going to expand today. And that's it. That's all you're going to work on or focus on is the expansion. So, here's the types of problems that we'll say. It will say something like this. Log base 2, 3 is equal to approximately 1.585. And log base 2, 7 is approximately equal to 2.807. Notice how they're different bases now, right? Okay, they're not base 10. So they somehow did this. And just so that you guys know, without using a calculator, you have to use what they call tables. And I've seen and used these log tables, and they're a pain in the butt. But what was done was, in some of the books I had in college, we'd have pages. One book alone for one of our classes was just a log book, where it had all the logarithms for all these different bases. We had to sit there and page through and look at it. It was painful. Okay? But they're giving you these two. And now here's what it's going to say for the problem. It's going to say log base 2, 3 divided by 7. Okay? So the first thing that you'd want to do is you'd want to expand it. What is division the same as? Subtraction. So that's the same as you saying log base 2, 3 minus log base 2, 7. Well, what number represents log base 2, 3? 1.585 minus what number represents log base 2, 7? 2.807. What do you get when you take 1.585 minus 2.807? You get negative 1.222. And you're done. Okay? So I expanded it in order to use those two numbers. Now, if you have the same numbers down, what happens if they give you log base 221? How can I use the 3 and the 7 that they gave us to make 21? They're multiplied, right? 3 times 7 equals 21. Yeah. So instead of writing it as 21, I'm really going to write it as log base 2, 3 times 7. And what's multiplication the same as? Adding. So that's really log base 2, 3 plus log base 2, 7. Or 1.585 plus 2.807, I think was what that number was, right? So what do you get when you add them? 4.392. Done. Okay? What if they give you log base 2, 49? You can have 7 and 7, right? Or 7 squared. Would that be the same thing? Yeah. 7 times 7 or 7 squared. Right? I'm going to show the squared just so that you see what happens with the exponent. Okay? So if I do log base 2, 7 squared, it's not the answer of 7. Okay? It's not where the base and the exponent are the same, so therefore you get 7. That doesn't cancel that way. But in order to expand, this deuce right there goes in the front. So it's 2 times the log base 2, 7. Or in this problem, 2 times 2.807. What is 2 times 2.807? Say it again. 5.614. And you're done. Okay? What do you think? Can you handle those? Yeah. That's half of your assignment, just like that. They will give you 2, and then you use those to make your answers. Okay, so they'll give you 2, like I did, and use those to make your answers. Is everybody okay with that? Awesome. Then, from here, here's what they're going to have you do. It's going to say expand ln of 5x to the 7th divided by y. Is ln follow the same rules as log? Yes. Why? What does ln refer to? What does it mean? What does it stand for? Not linear. I talked about it in section 2. ln is short for natural log. Okay, so in that problem, or in that way, I'm actually referring to logs. So do the properties or laws apply to these too? Yes. So when I'm expanding this, here's the first thing that I get rid of. Is there any division?
Yes.
Yes. What's division the same as? Subtraction. So therefore, I have the ln of 5x to the 7th minus the ln of y. So I got rid of the division first by subtraction, right? Because remember, division and subtraction were the same. Do I have any multiplication in my problem? Yes. If you say that first one out loud, you'd say 5 times x to the 7th. Now, most people screw that up. Most people then try to not separate the 5 and the x. But remember, you said 5 times x to the 7th. So are those two different things? Yeah. What's multiplication the same as? Addition. So then that ends up being ln of 5 plus the ln of x to the 7th minus the ln of y. Now, do you have any exponents? Where do they go? In front. What does it go in front of? All of it?
Just that.
Or just that part?
Just that part.
Just that part. It only goes to in front of the one that it is attached to. This 7 is only attached to this one right here, so it goes in front of that one there. So you have the ln of 5 plus 7, the ln of x, minus the ln of y. That's expanded. Is there any more division? Is there any more multiplication? Is there any more exponents? No. So therefore, you're done. Now, on that particular one, just so that you guys understand, I gave you one that has 3 different parts or 3 different laws. Are they going to always have all 3 to deal with? No. Is there any division? No, so therefore we're not even going to use that law. Is there any multiplication? Yeah, split it. How do I do that? Log 6, 3 plus log 6 x to the 4th. Now, is there any exponents? Where do they go? In the front. In front of what? Not in front of the log 6, 3? Nope. So log 6, 3 plus 4 log 6 x. Done. That's it. No more to do. One more just so that way you guys, when you see this type. The ln of 5 divided by 12x. Is there any division? So what's division the same as? So ln of 5 minus the ln of 12x. So far, so good? Is there any multiplication?
Yes.
The 12 times the x. But, here's the big but. 12x came from the bottom, right? So if you did this, if you went ln of 5 minus the ln of 12 plus the ln of x, you're wrong. Here's the reason why. If you were to re-put that back together, when we'll do that tomorrow, you would have 5 divided by 12, and then you'd have it times by x, which would be 5x divided by 12, not 5 divided by 12x. So one of the ways you can deal with this, if there's more than one thing that comes from the bottom, you can add in a set of parentheses around the bottom. That takes care of it, just by doing that. So if there is more than one thing on the bottom, you can put the bottom in parentheses and it takes care of the whole thing. That's acceptable. Okay? Here's the other alternative. If you don't want to use the parentheses, then you make them both minuses. If they come from the bottom, then they have to have a minus. So that means that subtraction is the division, so therefore it goes to the bottom. So either way you want to handle it is fine. I will accept either answer. Okay? So if you want to have it as both negatives because they came from the bottom, great. Or if you want to have a plus there and a parentheses around the whole thing, that's fine too. It does not matter to me which way you have it. Okay? What do you think? This is all you're doing for today. So on the first ones, again, if you read the directions on page 331, on 3 to 8, it says use log base 7.4 is approximately that number, and log base 7.12 is approximately the other number to evaluate the logarithm. 9 through 12 is matching. So you're matching which ones it would represent. 13 to 20, say expand. And that's it. Okay? So here's what you're doing. On page 331, 3, 5, 7, 9 through 12, and then 14 to 20 evens. And on the 9 through 12, it's all, because that's just matching.